Alright, this is like port, I think 4 of this unit, maybe 5, I don't know. Part 4 or 5 of this unit. We're making a kind of a, not really a DIY, but a home, not really even homemade, kind of homemade electric fence box. We're taking the guts out of an older, like 35, give or take, year old unit called a PEL 609, I think is what it was. Let's see here, 609, yeah, the PEL 609. The issue with it originally, with this unit, everything worked perfectly with it, but the transformer itself was bad. We were already getting like 1,000 volts out of it, and the transformer is down inside this epoxy filled resin, which is molded into the case. You can't get this base of the unit with the transformer. You cannot get those anymore. So what we've done, if you haven't seen part 1, 2, or 3, or 4, whatever how many parts are before this one, you might want to go check those out. The first one is me disassembling the first one. I made notes of which wire went where. I got a multiplier board, which is this board here. I got main power board, which I'm calling that, which is this board here. And so I labeled everything. You know, there's pins 1 through 4 here, 1 through 5 here, and I got on there which wire went where, so I know. Cause I don't have any of this memorized. I don't, you know, there's no wiring diagram out there, so I had to basically make my own, and we'll rewire everything. And then, so part 2 was I think starting to assemble and bolt in some stuff and get everything kind of lined out the way we wanted to do it. Part 3 was finishing up, bolting things in, getting the capacitors mounted, getting the transformer mounted, getting the cord kind of started where we want it. Got the fuse mounts off the old unit, the fuse holders, we got those, we're reusing those. We're basically reusing almost everything, but the transformer is different. And of course, this indoor-outdoor plastic case, we're reusing it, which is a latching type. It's supposed to be waterproof. I can't remember the IP rating of like IP68 or something like that. It's a pretty decent waterproof housing on it. There was an exhaust, or not exhaust fan, but a circulating fan, exhaust fan in here, 12-volt deal. I got rid of it. It's not being used. It's not for this application anyways. So anyway, so now what I'm going to do, I'm going to start trying to do some of the wiring for it. So the first thing I'm going to do, the easiest thing to do wire on here is the cord. So we're going to plug the cord onto the back side of the fuse holders. And then there was some wires on here, but I don't think they're going to be quite long enough to reuse, and they might be. We'll have to see. I need to get my cheat sheet out now so I know which wire is going where. So it looks like if you solder these wires on, they're going to go to the multiplier board. Looks like this is AC. There's no polarity of the AC, so it doesn't matter which black wire, white wire, which one it goes on here. As long as we put them on the 2 correct spots over here, it doesn't matter if white and black are reversed. But it looks like the white wire, we're going to do exactly the same, goes to pin 2, which it is long enough to reach over there. Black wire went from here over to pin 4. So I think the wiring for the cord is going to be long enough. So I need to get my wire strippers out, hide under this door here, get my solder out, so because we're going to have to solder the cord wires onto this. And here's the information. If you don't know or know who we are, here's our information right there real quick. And like and subscribe to our channel if you haven't already. We appreciate that. Share the video if you like electronics and repairs and DIY stuff, or I don't know, knowing how things work on electric fence boxes and electronics and stuff like that with these type of units, this type of equipment. That's all we specialize in, is working on these electric fence boxes. We do work on some cattle scales and load bars. We work on some of those as well. Don't work on a lot of them, but we do work on those from time to time. So what I'm doing is I'm coating the wires with solder. It's called tinning the wires. And what that's going to allow us to do is when we heat this up, since this has got solder on it, they're just going to basically flow right together, become one. Oh, it's hot. Woo! But you gotta let the solder kind of halfway cool off so that the solder, melt or hardens. So now what I want to do next is I didn't do this on, I did it on this board, but haven't done it on this one. I need to reflow and make sure the solder's in good shape on this board, which it looks like it is, but I'm going to reflow it and add a little fresh solder to it. Plus might need to give myself a little bit bigger surface area to solder to, so that's another thing, another reason why we're kind of reflowing it and everything. Okay, so it looks like the black wire from the cord went to number 4, which is that far one over there. So we're going to strip this off. Yep, that's going to be long enough. I had the wire a little too long and not quite long enough, because then you got a little room to play with, because if the wire's too short and you can't reach, you're going to have to put a new, get a new wire out and redo it. So you have to do the work twice, and I don't want to, I've already spent enough time doing this thing, kind of figuring things out. I just hope that I do this right. Because I know the unit itself was working just great, minus the transformer being bad. Alright, and the white wire went to, for the cord, went to number 2. Alright, we can cut some of this off. We don't need as much. So, yep, that'll be perfect. So now, bend that wire up a little bit. Come on. There. Tin the wire. Put solder on the back, iron on the back side, so it heats up, and then we'll put the solder from the front side. Okay, now let's go to the blue wire of the capacitor. That went to pin number 3 on the main power board. Okay, blue capacitor wire went to number 3, the power board, so that went right there. I still got to snug these wires up, or these bolts up there on that one, which I can do that now, I can do it later. I'll just do it later for now. So now we'll add a little solder to that wire to tin that one. Put the iron on the back side. And let the solder flow through the wire from the front side. That way it flows through, goes all the way through the wire. And then we should be able to keep the two up together. Let them cool down and harden up. Okay. Black wire the capacitor. Alright, so it goes to number 5. So there's actually going to be 2 wires on here. It looks like one's going to be from the transformer. So these two are going to go together basically. And then those are going to solder on to number 5. So we're going to snip off that one there. And then we're going to need it. Alright, so let's see this one here. Alright, so what we're going to do is we're going to strip this back. Quite a bit, actually, for what I'm having in mind. So we could take these two wires, we could twist them together, but what I want to do is I want to trim off some of these frilly things on there. Ow, my feet are killing me. We're going to coat this wire with some solder. We're going to coat, ow, come on, coat this wire in some solder. And then still pretty hot. Still pretty warm. And then we're going to fuse them together. And then I think we'll trim off a little bit of this. Let's okay. And then we'll take these wires, I'm going to go number 5. Okay, that's that. Now the red wire, which will be our off the old board, was going to be our white wire. So we're just gonna cut this spade connector off. We don't need it. And this wire should be long enough. It should just run right over there. So we're just gonna trim that back. Ow, feet. Okay. Okay, slowly but surely. Alright, so now we need to get this board wired over to here. So I'm going to have to use got this wire here. This is a number 14 gauge wire. I'm just going to cut off a bit of it, and then we can split it apart and use what we need as we need it, and cut it to length as we need it. Okay, so looks like it's like multiplier board. We've got pin 1 or spot 1, whatever, was a red wire, which I happen to have black and red here, so we're going to use red wire like we had before from from pin 1 of this board to pin 1 over here. So we'll just strip this back, and I will cut this wire length. I do not need that much wire at all. Okay. Come on. Should be able to heat them both up. Alright, so I went to pin 1, which is over here. So I'm just gonna do that. Oh, this is the fun part. I mean, this is the easier part of the whole job. Mounting it, figuring out how we're going to lay things out and bolt things in and all that fun. So that was a time-consuming part. Wiring it, soldering wires. I love doing that stuff. Come on. Come on. Hold there for a second. All right, there's that. Okay. Now, what else do we got? Let's get a pin out or something. We'll start check marking off stuff that we've done. All right, we got the red wire from multiplier board to this board from pin 1 to pin 1, so check. White wire cord, check. Oh, gotta do a black wire, so we got number 4 to check. Now we need a black wire from pin 3 of the multiplier board to pin 2 of the power board is what I'm calling it. So we'll strip off a little of this. Tin the wire here. And then we'll get our testing heat on those here. We're going to hold them side by side and heat them both up together, let them fuse together. Alright, and then that goes pin 3 to pin 2, which is right there. So we'll snip it a little long. Okay. Alright, they're all fused together, looking real good there. Okay. Get my marker back out. Check mark what else we've done so far. Okay, so this upper area is all done. Let's go down here. Red wire from 1 to 1, so that's the same thing as up above. Black wire, number 2. Black wire from pin 2 here to pin 3 over there. That's done. Blue capacitor wires on number 3. There's only one there, so that's done. See, number 4 was a red wire, which is our white wire, or they're a white wire, so that's that. Then we got 5 A and B, which was both black wire from the transformer capacitor right there. So, in theory, you know, if I plug this in, it should go to clicking. Honestly, that's what should happen. Let's see. Now we'll have to secure this cord. We'll probably put some glue on there. One thing I may still want to do, I gotta look at my LEDs, see if I have any like panel mounted ones, which I think I do. I could put it on the side of the box here, maybe right by this cord. I don't really want to put it on the front of the door, you know, because if it opens it up, it's going to pull on that cord and stuff like that. But let's plug it into a power strip here. And because the unit itself, before we started effing around with it, everything was it was good to go. Ow! Oh, I'm gonna count of 3. I'm gonna plug it in and see if the thing goes a clicking. 1, 2, 3. All right. Well, so far so good. F nothing up yet. Now I don't know what the transformer is going to put out with this unit, because this is not the same transformer. I think the factory one put out on the original one, I think the spec note on it in the box still that was still in there showed like 6.3 or something like that peak voltage. So let's look at this number here. I'm going to test across here to here and peak voltage out of it, see what it's going to read. $4,700 is all we're getting out of this thing. $5. Just because the transformer is not quite wound right with this board, so we may have to come up with a different transformer for this thing. What's this transformer here? I got this transformer here, came out of a Gallagher something or another, but I need to figure out what the model it goes with, make sure it's one that can handle the power that this one produces. Okay, well, let's just see, we'll just kind of go through the motions with it here. Let's see what kind of joules we get out of this thing. So you're not losing very many volts. We went from 4.9 to 4.6. We got 3 joules running through the 3 joule output so far. Let's go to a 200 ohm load. All right, we're up to 6 joules at 4,000 volts. So it's not losing very many volts. We went from 5 with no load, rough 4.9, 4.8 with no load, with the 200 ohm load. Which closer you get to 0 or 1 ohm across fence and ground, the worse the short is. So we went down to 200 ohm, and we only lost like 700 volts, and we're up to 6 joules. on the thing, roughly. Let's go to 100 ohm load. That's the heaviest load I got handy with me right now. Almost up to 9 joules. That's about what it's probably going to be at, because we're at 3.8 kV. And if we go much over 3 or much below 3.5, we're going to start losing our joules. So it's about a 9 joule unit. So in theory, this transformer would be fine. But of course, the customer's probably going to want to see higher voltage than that. So I'm going to have to play around here on my end, see if I can find a transformer. So that means I'm going to have to cut these stupid, I should have put that zip ties in there, but I was assuming, what happens when you assume? Get ahead of yourself. But electrically, it's doing fine. So I did my wiring and everything fine. Nothing's arcing to anything. I know the bolts aren't arcing to nothing. So I've done my job right so far. I just gotta get another transformer for it. I'm gonna try to wire up an LED to the thing. I've got a couple different panels. I got a green one, blue one, red one. So I'll probably get red or green or blue. I'll just use one of them. Whatever's brightest, I'll probably put a red one on. The red ones you can see from a pretty good distance. Green ones are the same way. You can see green ones from a pretty good distance as well. I might even have an 110 volt LED type of thing I might be able to put on there for so it knows the power's on. So I might put 2 LEDs, one for the power that you know it's turned on, and one for the clicking flashing. We might do that. So maybe, I mean, put a switch on. Maybe we'll wipe a switch for the guy so you can turn it on and off from the outside versus unplugging it from the wall. So I don't know. Let's just have to play with it, see what we want to do. Well, I don't know. I might make another final video on this. I probably end up well, but I got to play around with it first, and then we might make a final video of everything done. Because this is taking me like 2 hours to do, two and a half hours, whatever it is, to do this whole thing. Plus whatever I did originally on the unit when we first got it, when we first had it in for repair, that PEL unit. I spent probably 15 minutes, 20 minutes on it. So yeah, I got 2.5 hours, give or take, working on this thing. So luckily I charged them accordingly. I mean, we're not making a shit ton of money on the time that we spent on this thing. But to get something reliable like this, it would cost a small. Fortunately for the red light down there flashing, it costs a pretty penny. But these are good old units, PEL units. Anyways, thanks for checking our video. Until next time, see you guys later on. Maybe a part 4 or 5.